Betelgeuse's binary twin, the doomed star Siwarha. Betelgeuse's hidden secret: it has a binary twin, and its fate is sealed. Here's a cosmic revelation that's both thrilling and a bit heartbreaking. Betelgeuse, the famous red supergiant star, isn't alone. Astronomers have finally confirmed the presence of a smaller, dim companion star orbiting this colossal giant. But here's where it gets controversial: this companion is already on a doomed path, caught in the gravitational grip of Betelgeuse's final act. For years, scientists have speculated about the possibility of Betelgeuse having a binary partner, but detecting such a faint star next to a luminous giant seemed almost impossible. Now, thanks to cutting-edge observations, that mystery is solved. The tiny star's characteristics perfectly align with earlier predictions based on Betelgeuse's unusual behavior. Since Betelgeuse's name means hand of the giantess in Arabic, researchers have proposed calling this newfound companion Siwarha, which translates to her bracelet, a poetic nod to its orbit around the giant's hand. This discovery is a remarkable technical feat. Steve Howell, an astrophysicist at NASA's Ames Research Center, explains. Detecting this companion pushed the Gemini telescope's high-angular resolution imaging to its absolute limits, and it succeeded. This breakthrough paves the way for similar challenging observations in the future. Located roughly 548 light-years away in the Orion constellation, Betelgeuse is one of the most massive and brightest stars visible from Earth. It's a true behemoth, with a mass estimated between 16.5 and 19 times that of our Sun, and a radius about 764 times larger. Despite being only about 10 million years old, a blink of an eye compared to the universe's 13.8 billion years, Betelgeuse is nearing the end of its life. Massive stars like this burn through their fuel rapidly, shining intensely but briefly, before ending in spectacular supernova explosions that leave behind neutron stars or black holes. Betelgeuse offers a rare opportunity to study a star in its final stages, close enough for detailed observation. And it has certainly kept astronomers intrigued. One of the most puzzling events was the Great Dimming, when Betelgeuse's brightness dropped by an astonishing 35%. Scientists later traced this to a massive dust cloud ejected from the star, which temporarily blocked its light as it cooled. But Betelgeuse's brightness doesn't just fluctuate randomly. It has two main cycles: a dominant 400-day period caused by pulsations within the star itself, and a secondary, roughly 6-year cycle that puzzled researchers because it didn't match internal stellar activity. Recent studies suggested this longer cycle might be explained by the gravitational influence of a binary companion, precisely the star now observed. Detecting this companion was no easy task. Betelgeuse's immense brightness and size make spotting a faint neighbor extremely challenging. Howell and his team used a technique called speckle imaging, which involves capturing very short exposure bursts to counteract the blurring effects of Earth's atmosphere. Although the detection confidence is modest, about 1.5 sigma, it fits all the expected criteria. The companion is exactly where and when models predicted it would be. The companion, Siwarha, is estimated to have about 1.6 times the mass of the Sun and orbits Betelgeuse at a distance of roughly 4 astronomical units, AU, about 4 times the distance between Earth and the Sun. To put that in perspective, Siwarha is closer to Betelgeuse than Jupiter is to our Sun. This orbit results in a period of nearly 6 years, matching the mysterious brightness cycle. The researchers caution that their findings aren't yet definitive, given the limits of current instruments. Still, this represents the strongest evidence to date for a stellar companion to Betelgeuse and provides valuable insights into its properties. Interestingly, Siwarha appears to be an F-type star that hasn't yet reached the main sequence phase, meaning it hasn't started hydrogen fusion in its core. This highlights a fascinating cosmic paradox. While Betelgeuse is a massive star nearing the end of its life, its smaller companion is still in the early stages of stellar development. Both stars likely formed together, but their evolutionary paths are drastically different due to their mass difference. And here's the dramatic twist: Betelgeuse is expected to explode as a supernova within the next 100,000 years, probably leaving behind a neutron star. When that happens, Siwarha will be caught in the blast zone, facing an uncertain and likely catastrophic fate. Astronomers now have a limited window to study Siwarha in more detail, with the next optimal observation opportunity coming in November 2027. Over the next 2 years, they'll be refining their techniques to capture clearer images of this elusive, doomed star. This groundbreaking research has been published in the astrophysical journal Letters, marking a significant milestone in our understanding of one of the night sky's most iconic stars. So, what do you think? Does the discovery of Siwarha change how we view Betelgeuse's final days? Could this binary relationship influence the timing or nature of Betelgeuse's supernova? Share your thoughts and join the conversation, because in astronomy, every new discovery sparks fresh debates and endless wonder. The twinkling mystery of Betelgeuse, NASA solves centuries-old puzzle. Imagine gazing up at the night sky and seeing a mesmerizing red star twinkling above Orion's shoulder. For centuries, this star, known as Betelgeuse, has baffled astronomers with its mysterious fluctuations in brightness. But now, after hundreds of years of speculation, NASA has finally uncovered the secret behind its twinkling dance. NASA captured the first images of a companion star, affectionately dubbed Betelbuddy, which plays a crucial role in Betelgeuse's luminous performance. This discovery was made possible by the Gemini North Telescope in Hawaii, which boasts the capability to produce incredibly detailed and high-contrast images. Steve Howell, a senior research scientist at NASA Ames Research Center, expressed his amazement. Many papers suggested that observing Betelgeuse's companion would be impossible. Thanks to the advanced technology of the Gemini North Telescope, we were able to detect it directly. Betelgeuse, pronounced Betelgeuse, yes, the name inspired the iconic Halloween movie character, sits approximately 650 light-years away from Earth and shines 100,000 times brighter than our Sun. If it were placed at the center of our solar system, its surface would extend beyond Mars and even the asteroid belt. This colossal star is classified as a variable star, meaning it alternates between periods of increased and decreased brightness every 400 days. Additionally, it undergoes a longer cycle of change lasting around 6 years. The star's erratic behavior has intrigued observers since ancient times, with the renowned astronomer Ptolemy noting its fluctuations as early as the 1st century AD. In 2019 and 2020, Betelgeuse experienced a dramatic dip in brightness, known as the Great Dimming, leading some scientists to speculate that the star might be on the brink of a supernova explosion. However, it was later discovered that the star had expelled a massive gas bubble that cooled down to form dust, temporarily obscuring its light. This event reignited scientific interest in understanding the mechanisms behind Betelgeuse's twinkling. The hypothesis that a second star might be influencing Betelgeuse's brightness gained traction. However, both the Hubble Space Telescope and the Chandra X-ray Observatory failed to locate the companion. It wasn't until researchers employed a technique called speckle imaging that they finally spotted the elusive star. Speckle imaging involves capturing extremely short exposure shots to minimize atmospheric distortions, allowing for high-resolution images. When combined with the powerful light-gathering capabilities of the Gemini North Telescope, this method revealed the companion star for the first time. Martin Still, the program director for the International Gemini Observatory, emphasized the significance of this discovery. Solving the Betelgeuse puzzle, which has perplexed us for centuries, marks a monumental achievement. The newly discovered star is estimated to be about 50% larger than our Sun but hasn't yet ignited the full process of nuclear fusion that would make it more noticeable. It orbits relatively close to Betelgeuse, about 4 times the distance between Earth and the Sun, and is likely a cosmic sibling, formed alongside Betelgeuse. However, the companion's fate is sealed. Due to strong gravitational forces, it will eventually spiral into Betelgeuse and be absorbed within the next 10,000 years. This groundbreaking discovery was published in the astrophysical journal Letters, offering new insights into the dynamic nature of celestial bodies. But here's where it gets controversial. Could there be other stars in our galaxy with similarly enigmatic companions? And how many more mysteries lie hidden in the vast expanse of space waiting to be uncovered? What do you think? Share your thoughts on this fascinating discovery and whether you believe there are more cosmic surprises waiting for us.